Hello,
Hello,
am I
am I
audible?
audible? Yes, sir.
Okay.
Okay.
So,
So,
hello
hello
everyone.
everyone.
So,
So,
this
this
week
week
we are
we are
going to
going to
solve
solve
question
question
from
from
friction,
friction,
and
and
we
we
will
will
talk
talk
about
about
some
some
fundamental
fundamental
friction
friction
problem as
problem
well
as
as
well as
friction
friction
associated
associated
from the
from the
ladder
ladder
as well
as well
as
as
from
from
wage.
wage.
So,
So,
as
as
usual,
usual,
we will
we'll
first
first
look
look
few
few
simpler
simpler
problems
problems
where we
where we
do
do
the
the
force
force
balance,
balance,
and
and
we
we
try to
try to
calculate
calculate
the
the
various
various
normal
normal
reactions
reactions
and
and
external
external
force
force
by
by
doing the
doing the
force
force
balance.
balance.
But
But
the
the
only
only
difference
difference
is
is
this
this
time we
time
will
we will
consider the
consider the
effect of
effect of
friction,
friction,
and
and
then we
then
will
we will
move to
move to
different
different
kinds
kinds
of
of a
problems.
problem.
So
So
basically in
basically
the
in the
friction,
friction,
but
but
there are
there are
some
some
category
category
of
of
problem
problem
that
that
you
you
need to
need to
know
know
about.
about.
So
So
first is
first
the
is the
block
block
problems,
problems,
block
block
friction
friction
problems,
problems,
where
where
you
you
usually
usually
have
have
given the
given the
block,
block,
and there
and
is
there
an
is an
external
external
force which
force
is
which is
usually
usually
acting on
acting
the
on the
block, and
block,
you
and you
need to
need to
find
find
the
the
either
either
external
external
force or
force
the
or the
frictional
frictional
force.
force.
So
So
there will
there will
be
be
frictional
frictional
force in
force in
the
the
opposite
opposite
direction of
direction of
the
the
external
external
force,
force,
and
and
there will
there
be a
will be a
normal
normal
reaction which
reaction
is
which is
acting
acting
on the
on the
block
block
as well.
as well.
Then
Then
there are
there are
some
some
problems which
problems
are
which are
associated with
associated with
the
the
circular
circular
disc,
disc,
like
like
this
this
or
or
this,
this,
where
where
this
this
disc
disc
is
is
actually
actually
kept
kept
in an
in an
equilibrium
equilibrium
position,
position,
and there
and there
will be
will
a
be a
normal
normal
reaction
reaction
which
which
is
is
acting
acting
from
from
the
the
walls,
walls,
and
and
there
there
will be
will
a
be a
weight
weight
as well,
as well,
and we
and we
need to
need to
find the
find the
friction
friction
force
force
in
in
order,
order,
or the
or the
external
external
force in
force in
order
order
to
to
maintain
maintain
this
this
equilibrium.
equilibrium.
Then
Then
there
there
will
will
be
be
a
a
problems
problems
which
which
is
is
associated with
associated
the
with the
ladder
ladder
ones.
ones.
So
So
here
here
we
we
have
have
given a
given a
ladder
ladder
which is
which is
usually
usually
uh,
uh,
has
has
a
a
inclined
inclined
position,
position,
usually has
usually
an
has an
equilibrium
equilibrium
inclined
inclined
position,
position,
and
and
we have
we have
given the
given the
various
various
normal
normal.
so we have
We have
given the
given the
various
various
forces
forces
like
like
weight
weight
and some
and some
external
external
forces,
forces,
and due
and
to
due to
friction
friction
at a
at a
contact,
contact,
uh,
uh,
there
there
will be
will
a
be a
normal
normal
reaction
reaction
as well
as
as
well as
some
some
friction
friction
forces,
forces,
which
which
usually
usually
associated
associated
at the
at the
contact
contact
point,
point,
like
like
at the
at the
contact
contact
A
A
as well
as well
as
as
at a
at a
contact
contact
B.
B.
And
And
then we
then we
need
need
to
to
do the
do the
same
same
force
force
balance
balance
as well
as
as
well
the
in the
movement
moment
balance
balance
to
to
determine
determine
the
the
external
external
force
force
or
or
some
some
unknown
unknown
friction
friction
quantity.
quantity.
Then
Then
there
there
are
are
some
some
problems
problems
like a
like a
wage
wage
problems,
problems,
where
where
what
what
happens,
happens,
you
you
usually have
usually
a
have a
block,
block,
uh,
uh,
let's say
let's say
this
this
kind of a
kind of a
block,
block,
and there
and there
will be
will
a
be a
wage
wage
associated
associated
with
with
it.
it.
Then
Then
you
you
need
need
to
to
consider
consider
this
this
block
block
and
and
wage
wage
as a
as a
separate
separate
one,
one,
and do
and
the
do the
force
force
balance
balance
analysis
analysis
separately
separately
for
for
this
this
block
block
and
and
for
for
this
this
wage.
wage.
So
So
by
by
doing
doing
this, you
this, you
can
can
actually
actually
determine
determine
the
the
external
external
force
force
which
which
act
act
on the
on the
wage,
wage
and
and
which
which
can
can
move
move
this
this
block,
block,
which
which
can
can
move
move
this
this
upper
upper
block
block
either
either
upside or
upside
the
or the
downside.
downside.
So
So
for
for
example, if
example,
you
if you
pull
pull
this
this
wage,
wage,
what
what
happens,
happens?
it
It
will
will
create
create
some
some
friction at
friction
the
at the
contact
contact
between the
between the
block
block
as well
as
as
well
the
as the
wage.
wage.
So
So
either
either
it
it
can
can
move
move
up
up
if
if
the
the
force
force
is
is
from
from
right to
right to
left.
left.
Therefore, the
Therefore, the
wage
wage
will,
will,
sorry,
sorry,
block will
block will
try to
try to
move
move
up,
up,
and if
and
you
if you
pull
pull
it
it
down,
down,
then it
then
will
it will
try to
try to
go
go
down.
down.
The
The
block will
block will
try to
try to
go
go
down,
down,
and this
and
has
this has
happened
happened
because
because
of
because
the
of the
number of
number of
forces which
forces
is
which is
acting on
acting
the
on the
system. For
system. For
example,
example,
like
like
weight,
weight,
normal
normal
reaction,
reaction,
and the
and the
frictional
frictional
force
force
at a
at a
block
block
as well
as well
as
as
at the
at the
wage,
wage,
and the
and the
external
external
forces,
forces,
and if
and if
given,
given
the
the
weight of
weight
the
of the
wage as
wage
well.
as well.
So
So
by
by
doing
doing
the
the
force
force
balance,
balance,
we
we
can
can
actually
actually
calculate
calculate
all
all
these
these
forces
forces
and all.
and all.
So
So
these are
these are
some
some
kind of a
kind of a
problem
problem
which
which
we
we
studied
studied
in
in
this
this
chapter
chapter
friction.
friction.
So basically the fundamental concept is to do the force balance that we have been doing since 3 weeks, but with the extra force like a friction force. It's a additional substitution into the force balance. So let's start with the first problem. So here we need to determine the minimum horizontal force P required to hold the crate from sliding down the plane. The crate has a mass 50 kg and the coefficient of static friction between the crate and the plane is μs, which is 0.25. So first let's make a free body diagram. So we have a crate and there is a external force which is acting, and we need to find this horizontal force P which can hold the crate from sliding down the incline. The inclination angle is 30. Now there will be a weight which is acting, and there will be a normal reaction. Now we need to determine the external force P which holds the crate. Otherwise, this crate or this box will go down. So the friction will act in the opposite direction, which is this direction. Let's say it is Fs, and this is angle 30. So let's consider I am considering this coordinate system. So this is 30 as well. So now we have made the free body diagram. We can actually easily determine which are the forces which is acting on the system. So we can easily identify the horizontal and the vertical component of the force. So first, let's do the force balance in the vertical direction. And in the vertical direction, we have normal reaction force N. And then due to the weight as well as due to this external force P. So due to the weight we have minus W. So sorry, it's cos 30. And here we have minus P sin 30 equal to 0. So this is equation 1. And then we write down the force balance in the horizontal direction, which is friction force plus external force and the weight, the component due to weight, which is equal to 0. So this friction force can be written as mu s multiplied by normal reaction, and we have given mu as 0.25. So the friction force can be written as 0.25 multiplied by n. So now we need to solve these two equations in order to determine n as well as p. So n and p are the unknown variables, and we have two equations to solve. And w is mg, which is 50 multiplied by 9.81. So let's take equation 2 first. So we have 0.25 and plus p cos theta equal to 50 multiplied 9.81 sin theta. So it will be 245.25. So I can write n as n equal to 245.25 minus p cos theta divided by 0.25. Let's say this is my equation 3. Now I can substitute this expression of n in the equation 1. So from equation 1 I can write n as n equals w cos theta plus p sin theta, which will be 424.785 plus p sin theta. So this is the expression of n. So I can equate this expression and the equation 3 with each other. So I will have 424.785 plus p sin theta equal to 245.25 minus p cos theta divided by 0.25. So when we multiply 0.25 at left hand side, we will get 106.19 plus 0.25 p. So the sin theta I can write as 1 by 2 equal to 245.25 minus 0.866 p. And here I can write 0.125. So it will be 0.125 p plus 0.866 p equal to 245.25 minus 106.19. So this will be 0.991 p equals 139.06. So I will get PS 140.322 Newton. So this is the value of external force which we require in order to hold the object from sliding. Now if we substitute p in equation 3 or any of this equation 1, 2, 3, we will get n, value of n. And if you find the way, if you try to find, the n will come out to be 494.6 Newton. But we required to calculate p and we got PS 140.322 Newton. So just to recap, we need to find the external force P in order to hold the object. And first we made the free body diagram where we actually include the effect of friction, unlike previous cases, unlike in the previous example we have seen in the previous weeks. And then we do the usual force balance exercise to determine the external force. So, any doubt in this question? If not, then we can move to the next question. So in the next question, we have determined the minimum coefficient of static friction between the uniform 50 kg spool and the wall so that the spool does not slip. So we have given the spool and we have given the weight which is acting, and we need to determine the coefficient of friction mu s so that the spool does not slip. So as usual, we need to first make the free body diagram. So this is at angle 60. And the forces are weight. Here we have a normal reaction due to friction force. And this is 0.6 meter. And this is 0.3 meter. So in order to find the unknown coefficient of friction us, again we can do the force balance in the fx and fy direction, or in the horizontal and vertical direction, or we can do the moment analysis at any point, either at center or at point A. So if I do the moment balance at point A, then I can actually determine some relation of T, right? Because this is the tension which is acting from some distance from center to point A, and I can, so there will be a movement from this tension, there will be a movement due to the weight, and I can actually relate my tension with the weight. If I do the movement balance at point A, because then I don't need to consider these forces. If I do the movement balance at the center, then I need to consider the friction forces as well. But in order to write the tension force in some component like weight or in some force normal reaction, something like that, let's do the movement balance at point A, because then we can directly consider the tension force as well as the weight force. So I will get weight, which is acting 0.6 meter from point A. So my counterclockwise is positive here. Then there will be a horizontal component as well as the vertical component of tension. So there will be a horizontal component as well as a vertical component of tension, and both will create the movement. So this tension force will be acting here, and both will create the movement here. So the horizontal component given by, so it will have a clockwise movement. You can see around a point it will rotate like this. So it will rotate in a clockwise sense. So this will be minus. So the horizontal component will be T sine 60 multiplied by 0.3, because here it is acting. This is the horizontal component Tx, which is 0.3 meter from point A. Then there will be a vertical component of tension Ty. Let's say it acts here. This is my Ty. We know the distance, which is 0.6 meter from point A. The Ty can be given as T cos 60 multiplied by 0.6 equal to 0. So now you can see from this equation that we can write T in terms of weight. And weight is 59.81 multiplied by 0.6, 0.3 T sine 60 minus 0.6 T cos 60 equal to 0. So this will be 294.3 minus 0.259 T minus 0.3 T equal to 0. So 294.3 equal to 0.559 T. So my T will be 526.475 Newton. So this is my tension. And now I can do the force balance analysis. So if I do in the horizontal direction, where the force from left to right will be positive, I have normal reaction, I have horizontal component of T. So these are only two forces in the horizontal direction. So it will be T sine 60 minus and A equal to 0. So my NA is T sine 60, which is T is 526.47. NA will be 455.93 Newton. And then we do the vertical force balance. We have a vertical component of tension, we have weight, and we have this friction force, which is mu s Na. So we already found normal reaction, we know weight, and we already found the tension as well. So by balancing these forces, we can actually easily get the coefficient of friction. So if you do the force balance in the vertical direction and the positive force I am taking in the upward direction, then I have T cos 60 minus energy plus friction force so we know T, which is 526.475, and the weight is 50, and my friction force is mu s, and my normal reaction is 455.93 equal to 0. So this will be 263.23 minus 490.5 plus 455.93 mu s, or I can write in the right hand side the minus sign. So it will be minus 227.27 equal to minus 455.93 mu s. So mu s will be 0.498. So this is the coefficient of friction we got. So just to recap, we have a disc which is attached to a wall by a rope, and we need to find we have given the weight, and we need to find the coefficient of friction, and the only force we have given is the weight. So when we draw the free body diagram, we can identify other forces which act due to friction. So there are overall four kind of force: weight, tension in both vertical and horizontal component, as well as the friction force. You can also add the normal reaction. So I can fill up the tension. So we have four kind of force: weight, tension, normal reaction, and the friction force. So by doing the force balance, so first we did the movement balance analysis, where we actually calculate the tension. We take the movement around point A, so that we can take all the forces which are not acting at A. So the forces which are not acting at A are tension as well as weight. So we define tension in terms of weight, and we found tension as 526.475 Newton. If we take a movement at the center, then the movement will be created by this friction force as well as the normal reaction. So just to give an idea, then we did the force balance analysis in the vertical and horizontal direction, where we balance all the horizontal as well as vertical force. So it will give the details about other forces like a normal reaction as well as the friction force. So by doing this, we actually calculate the coefficient of friction. So it's just a similar procedure doing the force and moment balance analysis. So any question in this? Any doubt in this problem? If not, then we can move to another one. So here we have the coefficient of static friction between 50 kg crate and the ramp is 0.35. The unstretched length of the spring is 800 mm and the spring constant is 660 Newton per meter. What is the minimum value of X which the crate can remain stationary on the ramp? So there is a crate and there is unstretched length. Let's say this is my unstretched length which is 0.8 meter. Now due to the weight, what happens that the crate will move down. So this is my unstretched length, and when it's moved down, there is a distance which is, let's say, x. And after this distance x, the crate will remain in a stationary position because the spring will have a limit. It cannot keep compressing. It will reach some distance x from point A. From point A to some x it will reach, and after reaching there, there will be a force acting due to friction as well, which is opposing the friction. So there is a force due to a spring which is acting in the opposite direction, and the friction also acting there. And due to the balance between these two forces, now the crate will not go below x because the force is acting due to spring as well. So it is restricting the crate to go further beyond x. So there will be a distance x where the crate will remain now in a stationary position, and it will come from point A to x. So this is my that distance x. This is my new distance, and this is my old distance. So the force due to the spring will be then given by k multiply 0.8 minus x. Okay, because this is the distance we need. This is the distance which is 0.8 minus x. So it will cover this distance. Block is covering this amount of distance. And therefore the force will be k multiply 0.8 minus x. K is my spring constant. So now we have to do the force balance analysis. So by doing the force balance analysis, we can consider the weight of the crate, spring force, friction force. We can equate all these forces with each other, and then we can actually calculate the unknown quantities like x. So there will be a force due to spring. Let's say it is Fx. Now since the block is moving from right to left, and therefore there will be a friction in opposite direction from left to right. So there will be a friction here from left to right, which is F. There will be a normal reaction due to friction, and there will be a weight which is acting 50 degrees from the vertical direction. And this is my coordinate system, X and Y. So just to again explain the concept, so first the unstretched length is 0.8 meter. This is my 0.8 meter, and due to the weight, the crate will go down, and it will go down up to some certain length X. And after that, it will come into equilibrium position. It will not move further. And we need to find that length X. So the force we have is the spring force, which is given by this relation, K multiplied by distance, and the distance it covers is this 0.8 minus X. So this is the old position, and this is now the new position of the crate. So this is one force. The second force is weight of the crate, and the third force is friction force, and there is a normal reaction due to the friction force. So let's do the force balance in the X direction. So this is my positive direction I'm considering. So we will have Fs plus friction force plus the component of weight, which is going down here. So it will be minus W sine 50. So this is my equation 1. And in the vertical direction we have the component of weight, which is minus W cos 50 plus normal reaction. So from equation 2 we can easily find the normal reaction first, which is W cos 50 and we have given the weight, which is 50 kg and the mu is 0.33 हो गया. So we will have a normal reaction, which is 315.287 Newton. Then we can use equation 1, which is given by so here you will have K 0.8 minus X plus mu and minus 50 9.881 sine 50 equal to 0. So we know K, which is 660 Newton per meter, 0.8 minus x, and the coefficient of friction is 0.35, and the normal reaction we got 315.287. So here we have 528 minus 660x plus 11035 minus 375.744 equal to 0. So here we have 660x equals minus 262.606. So x will be 0.397 meter or 397 millimeter. So this is the value of x. So again we use the same principle, force balance principle. So in the last question we actually found the coefficient of friction. Here we found the distance where the position of a block will become stationary. So we do the force balance due to the friction force, the spring force, friction force, normal reaction and as well as the weight. So any question here? So let's move to the next one. So again this is a incline problem, incline and block problem. So the coefficient of kinetic friction between the 100 kg box and the inclined surface is 0.35. Determine the tension necessary to pull the box up the surface at a constant rate. So here it is a straightforward problem because we need to find the unknown force, which is a tension in this case. So first we make a free body diagram. Now you can see in the diagram the arrangement of the rope is like this, and there is a tension in this part of the rope which is T, and there will be a tension in this part of the rope as well which is T, as well as this part which is again T. So the overall tension inside the rope, inside this configuration is T, T, T. So the overall tension will become 3T because of the arrangement of the rope we have given. So here we will have T. At the
At the
middle
middle
one we
one we
have
have
T,
T,
and
and
here
here
also
also
we
we
have
have
given,
given,
which
which
is
is
T.
T.
So the
So the
overall
overall
tension will
tension
be
will be
3T
3T
here.
here.
So
So
there
there
will be
will
a
be a
3T
3T
force,
force,
which is
which
the
is the
external
external
force
force
here.
here.
And
And
this
this
will be
will be
our
our
weight.
weight.
This is
This
the
is the
normal
normal
reaction,
reaction.
and the
And the
friction
friction
force will
force
be
will
in
be in
this
this
direction,
direction.
because the
Because the
movement
movement
is
is
in the
in the
upward
upward
direction, so
direction, so
friction will
friction will
act
act
in the
in the
downward
downward
direction,
direction,
which
which
is
is
small
small
f.
f.
And
And
now
now
we
we
can
can
usually
usually
we
we
can do
can
the
do the
usual
usual
exercise,
exercise,
which is
which
the
is the
force
force
balance.
balance.
And
And
again,
again,
this is
this is
my
my
x,
x,
and
and
this
this
is
is
my
my
y.
y.
So
So
let's
let's
do the
do the
force
force
balance
balance
analysis.
analysis.
And
And
I'm
I'm
taking the
taking the
direction,
direction
okay.
of it.
So in
So
the
in the
horizontal
horizontal
direction, it
direction,
will
it
be
will be
from
from
minus
minus
3t.
3t.
And the
And the
component of
component
the
of the
weight,
weight,
which
which
is
is
W
W
sine
sine
theta.
theta.
Oh,
Oh,
there
there
is
is
a
a
friction
friction
force
force
also,
also,
plus
plus
F.
F.
And friction
Friction
force
force
is
is
mu
mu
s
s
n.
n.
So
So
we
we
need to
need to
find
find
the
the
normal
normal
reaction
reaction
first.
first.
And the
And the
normal
normal
reaction
reaction
can be
can be
balanced
balanced
by the
by the
weight
weight
if we
if we
do
do
the
the
force
force
balance in
balance
the
in the
vertical
vertical
direction.
direction.
So it
So
will
it will
be
be
N
N
equals
equals
W
W
cos
cos
60.
60.
So my
So my
N will
N will
be
be
100,
100,
9.81
9.81
cos
cos
60.
60.
So
So
my
my
N
N
will
will
be
be
490.5
490.5
Newton.
Newton.
Now I
Now I
can
can
use
use
equation
equation
1,
1,
3t
3t,
100
100,
9.81
9.81
multiplied by
multiplied by
sin
sin
60
60
plus
plus
the
the
coefficient of
coefficient of
friction
friction
is
is
0.35
0.35
multiplied by
multiplied by
normal
normal
reaction,
reaction,
which
which
is
is
490.5.
490.5.
So it
So
will
it
be
will be
minus
minus
3t
3t
plus
plus
849.57
849.57
plus
plus
171.675
171.675
equal
equal
to
to
0.
0.
This will
This
be
will be
minus
minus
1021.245.
1021.245.
So my
So my
tension will
tension will
be
be
340.4
340.4
Newton.
Newton.
So
So
this is
this
my
is my
tension.
tension.
So the
So the
only
only
new
new
thing in
thing
this
in this
problem
problem
is
is
to
to
determine the
determine the
tension in
tension
the
in the
cable,
cable.
and due
And
to
due
the
to the
arrangement,
arrangement,
zigzag
zigzag
arrangement of
arrangement
the
of the
cable,
cable,
we
we
actually
actually
told
told
that
that
there will
there
be
will be
a
a
addition
addition
of the
of the
tension
tension
force
force
which is
which is
acting
acting
here.
here.
So
So
there
there
will be
will
a
be a
force
force
total
total
tension which
tension which
is
is
3t,
3t,
which
which
is
is
acting
acting
in the horizontal direction, and all other things were same. Then we have a force like tension, we have a friction force, we have a normal reaction, and we have a weight. And we balance these forces to calculate the unknown force, which is the tension. So any doubt in this one?
Sir, we're taking question of friction is kinetic friction.
Yeah, your your voice is very breaking. Actually, it's not clear. Your voice is breaking. I think you are not audible properly. Can you write the question? I can try to explain. So basically, we need to consider the coefficient of friction which is given in the question, whether it is a kinetic friction or the static friction. But if you have, let's say you have given the both coefficient of friction, one is static and one is kinetic, and then you need to consider the coefficient of friction according to the problem. If it is a impending motion, then you need to consider the static friction. And let's say there is a block which is continuously moving, and it is not in equilibrium position, it is just a moving. Then you need to consider the kinetic friction. And let's say if there is a problem where the block is moving and there is a rope, and this rope try to make the block in an equilibrium position such that the movement will stop due to the rope as well as the friction on the other side. And in that case, you need to use the static friction, because the static friction don't allow the block to move. And kinetic friction is, we use the coefficient of kinetic friction when the block is moving, because there is a rough surface, right? So even if the block is moving, it will continue to experience the friction. And in that case, we will be using the kinetic coefficient of friction. But if the block is not moving and we keep applying the force, we keep applying the external force, which is P, but the block is not moving, because there is an opposite force, opposite friction force, which is acting. And since the opposite friction force is more than the external force P, the block keep remaining in a stationary position. And in that case, you have to use the static coefficient of friction. But now you keep increasing the external force. Then there will be a point where the friction as well as the external force are equal to each other, and that is your impending motion. Because after, if you increase the external force after that, then the block will start moving. So after that point, you need to use the kinetic coefficient of friction. So that is beyond the impending motion. Impending motion, you have a external force which is equal or less than the friction force, and the block is always remain in a stationary position. So in most of the problem, we actually try to calculate the force at an impending motion, because the maximum force or the maximum friction force you will have, which is mu s n. So here this is the case for the impending motion, where you have a external force which is acting, and it is actually equal to the friction forces. So that's the impending motion. So till that case, you have to use the static coefficient of friction. And after that case, when the external force go beyond the friction force, then you can use the kinetic coefficient of friction, where the block is just moving. It is moving in some direction, and there is no equilibrium position of the block at all, and there is a friction which is acting, and there is a movement also of a block from, let's say, in the right direction, and here you will have a kinetic coefficient of friction. In a question, if you have given one coefficient of friction, it could be static or it could be a kinetic one. You have to use that coefficient of friction. But if you given two, then you need to decide based on the position or based on the problem statement given. So if you have a doubt, I mean, if it is still unclear, you can write down the
So if
question.
in the same problem it was asked what
Yeah,
is the
yeah,
force required to
yeah. There will be a same formula. It will be
no, no. If it is in the same problem, if it was asked what is the force required to start the motion of the block, then it will be definitely more than this what you are
yeah,
calculated, right?
yeah. Then there will be some static coefficient of friction which should be more than 0.35, because if you see the diagram, friction force versus external force, what happens that so I am actually increasing the force, external force. So you will have a diagram something like this. So what happened, till here the block is at rest because my friction force is greater than my external force, and this region actually determined by static coefficient of friction. But if and then this is the region where my external force is greater than friction force, and in this region what happens, the block start moving. So this region determines by kinetic coefficient of friction, which is usually always less than the static coefficient of a friction. So if there is a static coefficient of a friction, then it will be more than 0.35 in this case. And now depending on the problem, you can use either static or the kinetic one. So here in this problem, it is said that the block is moving upward. So block is not in the equilibrium position. Block is moving in an upward direction, and therefore they have given the coefficient of friction, which is 0.35.
Okay.
So let's move to the next problem. So now we start some different kind of a problem. So until now we looked a block kind of a problem as well as a disk kind of a problem. Now we start solving some ladder kind of a problem, where we have a given a ladder and it is in a equilibrium position with respect to the wall, the horizontal wall as well as the vertical wall, and we need to find the magnitude of a friction force as well as the angle, maximum angle, providing the condition that the ladder will not slip. So we have given the mass of the ladder or the bar here, which is 4 kg. We have given the coefficient of friction between the point of contact between a bar and wall, horizontal as well as the vertical wall, which is 0.3. And first we have given the angle, which is 20 degree, and we need to find the friction force. So as usual, we need to first draw the free body diagram. And here we have normal. So this is my point A, this is my point B. Here we have a normal direction and A. And if this bar falls, it will fall like this, like this. So the motion will be in the right direction, like this. So the friction force will act in the left direction. And at the same time, it will go down like this. So it is in this position, and it will go down like this. So the friction force will be in the opposite direction, in the upward direction. And this is my normal reaction at B and the friction force at B. There will be a weight as well, I think, yeah, which is 4 kg So it. And the angle of inclination is alpha here, and we have given a distance which is 1 meter. So now we do the force balance analysis. So when we take the summation of force in the horizontal direction, we will have two forces in the horizontal direction, which is friction force and the normal action at B. So it will be NB minus FA equal to 0. So it will be NB minus mu and A equal to 0. So let's say this is my equation 1. Then we do the force balance analysis for the when we do the force summation of force in the vertical direction, and we have three forces FB, W and NE. So it will be FB plus NA minus W equal to 0. And this is mu NB plus NA minus W equal to 0. So my W is 4 multiplied 9.8, it's 4G, which is 39.24. This is my equation 2. So from equation 1 I can write NB as 0.3 NA So when I apply this expression in the equation 2, I can write 0.3 NA plus NA equals 39.24. So it will be 1.09 NA equals to 39.24, and NA will be 36 Newton. And from equation 1 we can find NB as well. NB will be 0.3 NA. So my NB is 10.8 Newton. So these are my normal reaction due to the friction force of the wall. And we need to find the friction force which is acting at a flow here. So we need to find FA. So my FA will be mu NA, so it will be 0.3 multiplied by 36. So it will be equal to NB, which is basically this equation. Which is 10.8 Newton. So this is the friction force which is acting at the floor. In the next part, we need to find the angle for which the bar will not slip. So if we do the moment balance analysis, so if we take a moment at B, then the moment will be created by W, NA, as well as this force FA. So the moment will be given as, and I am considering the moment which is positive in the anti-clockwise, so it will be W, and this distance so I need this distance, so it will be 0.5 sin alpha multiply 0.5 sin alpha. So this is my 0.5. This is my 0.5 here, and this will be 0.5 sin alpha in the negative direction, because it is creating a clockwise movement which is negative. Then N is creating the anti-clockwise movement around point B. And this is sin alpha. And my friction force FA is also creating a clockwise movement, like in this direction around B. And here we need to consider this distance. This distance. So which is minus FA cos alpha equal to 0. So we already know all these quantities like normal reaction Na, friction force Fa and W. And we can easily calculate alpha from it. So the W will be 39.4 by 2 sin alpha plus Na will calculate 30 sin alpha minus 10.8 cos alpha equal to 0, and this will be around 19.2 plus 36 sin alpha equals 10.8 cos alpha. And when you solve this, you will get alpha which is around 31. So just to calculate the angle, we actually take the moment at B and we do the summation of all the moments, which is summation of all the moments caused by the force which is exerting at point A, as well as the weight which is not acting at a line of B, and that will give me alpha. And to calculate the friction force, we just do the summation of force in horizontal as well as the vertical direction, and that will give us the friction force. And in that case, we already know alpha, which is 20 degree. And to calculate the alpha, we do the moment balance, and then we create the, so we actually solve for the unknown alpha, which is at around 31. So any question here?
So I think in actual problem it is given as neglect the friction between wall and the bar, but we have considered friction with both the points.
Oh, okay, yeah. Okay, so we need to neglect the friction here, okay. Yeah, in that case, this FB will be 0, but there will be a normal reaction from wall. So NB will not be a 0, but FB will be a 0. So in that case, this will be, this flow as 0, this quantity will go as 0, and then we will have NA equals to W. Okay, and okay, this will change the NA actually. So NA will come out to be around 39.24 here. It is 39.24. And so that NB will also get changed. Yeah, I mean the analysis will be similar. It just we have to consider these force as a 0. And the remaining analysis will be the same. And in the second part where we calculate the angle alpha, we actually take the moment at B. So we don't need to care about, we already don't consider FB because the movement caused by FB will be 0. So it doesn't make much change. But yeah, since the value of NA and FA will now change, the alpha will be different, but the procedure will be remain same. So try this question by yourself. It has a similar procedure. It will just give the different numerical result.
Alpha will be more, I think. Alpha will be more because NA is more, so friction at A will be more.
Yeah.
The value of alpha will be more.
So this is sin alpha, this is cos alpha, and I can write W plus NA by FA, which is cot alpha.
No, alpha will be less, I think.
Yeah.
This will add up.
So there will be a change in NA as well as, sorry, this is FA, as well as, but it is related. So yeah, alpha will be less now. Okay, try to solve this problem by yourself. Then, if not, then we can discuss next week. Then, as of now, move to the next one because I want to touch the wedge problem as well. So let's solve the disk problem now. So here we have given the radius, a disk of radius 40 kg, homogeneous cylinder, or it's a cylinder, and the radius is given as 0.15 meter, and we have a slanted wall which is smooth at an angle 30. The coefficient of static friction between the cylinder and the floor is μs 0.2, and we need to determine the couple M, which can be applied to the cylinder without causing it to slip. So there is a friction here only between the floor and the cylinder, and no friction between inclined wall and the cylinder now. So first let's make a free body diagram. So there will be some normal reaction here, P, and there will be a weight, and sorry, this is my weight and this is my movement. There will be a normal reaction here and the friction force. And we need to consider the movement here. Sorry, we need to find the movement here. Let's say if we take a movement around center, summation of a movement around center, where the anti-clockwise is positive, then there will be a movement there will be an external movement which is positive, and then there will be a movement due to this force. This force will not create any movement because it is in a line of action, and so does this force. So only friction force will create a movement which is in an anti-clockwise direction, so it will be negative F, and the distance is the diameter of the cylinder. So it will be mu and r equal to 0. And in order to calculate this movement, we need to calculate normal reaction. And in order to calculate the normal reaction, let's do the summation of force in the vertical direction. So we will have N minus W, and we will have this force, normal reaction for P, which is acting here. So it will be, sorry, this will be alpha, this is theta, this is 90. This is alpha, this is 90, and this is P, and in the vertical direction we will have a P cos alpha, and here we will have P sin alpha, or this is P sin alpha. So we will have P cos alpha equal to 0. So in order to find N, now we have to find P as well. So now let's do the force balance and summation of force in the horizontal direction. And here we have P sin alpha minus friction force equal to 0. So I can write P sin alpha equal to mu N. So I can write N as P sin alpha by mu. So P, alpha is 30 and mu is 0.2. So my normal reaction is P sin 30 by 0.2. So it will be 2.5 P. So this is my normal reaction in terms of P. And now if I put in equation 1, I can write this as 2.5 P. We know W, we can find P here. But we don't need to find P because we need to find P here. So from equation 1, we have N and the W is 40G plus P cos 30 equal to 0. Alpha is 30. And my normal reaction is 2.5 P that we have found above. So it will be 2.5 P minus 392.4 plus 0.866 P equal to 0. So this will be 3.366 P equal to 392.4. So my P will be 116.57 Newton. And if N is 2.5 P, then my N will be 2.5 multiplied by 116.57. So my normal reaction will be then 291.443 Newton. Then I can use this moment balance relation now, because now we found the normal reaction. So we will have M equals mu and R. So my M is 0.2 is my mu, N is 291.44, which we found here, and my R is 0.15 I think. Yeah. So my M will come out to be 8.743 Newton. So this is my moment which we required to find. So just to recap, we are given the weight of the cylinder, friction force, normal reaction, and normal reaction P due to the inclined wall as well. And we need to find the unknown moment N. So first we did the moment balance analysis, because if I do the moment balance analysis at point at the center of this cylinder, then I will get an idea which force I need to found. So here from this moment balance analysis, I got to know that I need to find this normal reaction N. And to find this normal reaction N, we do the summation of force in both vertical and horizontal direction. So first we found N from P. So P is also unknown normal reaction force. So first we found P, then we found N, and then we substitute the value of N to find the external moment value N. So any question? Any question? If not, then we can look one more similar kind of a problem. So here we have a 45 kg disc rest on a surface for which the coefficient of static friction is mu a 0.2. Determine the largest moment M that can be applied to the bar without causing motion. So here we have a disc as well as a bar, and there is a friction between surface as well as a disc. So we have a friction here. So if I make a free body diagram, then due to this joint at B, we will have a normal reaction, which is Bx as well as By, and we have given the weight of a disc as well, and there will be a normal reaction as well as friction at point A. So to one way to find the movement, so first we need to consider bar only. Let's say we consider a bar first, and there will be a force due to this joint, which is Cx and Cy, and then there will be a force at this joint also. So there will be a reaction. So Bx and By, and there is an external moment which is acting and which we need to find. So if we do the moment balance analysis or the force balance analysis in this bar, then we need to know about these forces Bx and By. If we calculate these forces Bx and By, then we can actually do the moment balance analysis at this point, at point C. So we can exclude this force, and the moment will create due to this Bx and By. So we already know then what is the value of Bx and By, and by doing the moment balance analysis, we can actually calculate this unknown moment n. So for that we need to do the moment. We need to take the summation of moment at point C and consider the movement due to these forces Bx and By, and to calculate Bx and By, we can do the force balance analysis in a disk system. So first let's only consider a disk system and do the force balance analysis here, or we can also take the summation of movement. So let's say this is my O. If I do the summation of movement at O, then the movement will be caused by this friction force Fa and this reaction force By, this one. Bx is actually in a line of contact, and this force is also Na is also in the line of contact. So this will be zero. This will not create any movement. So the movement will be caused by By as well as Fa. So Fa will create a clockwise movement. So it will be minus Fa multiplied by radius, which is 125 or 0.125 meter, and By is actually creating a anti-clockwise movement around point O. So it will be By plus 1.25 equal to 0. So this will give me By 0.125 equals Fa 0.125. So By equals to Fa and By equals to mu Na. So let's say this is my question 1. because we don't know NA. So to know NA, let's take the summation of force in the horizontal direction. So here we will have minus FA plus BX. So my BX will be FA. So BX will be mu NA. And this is my equation 2. So from equation 1 and equation 2 we can see that By will equal to Bx, which is equal to mu NA. So now we do the summation of force in the vertical direction to see if we can get NA. So in the vertical direction we have W, we have By, we have NA. We have three forces. So it will be NA minus W minus By equal to 0. So my NA is unknown. My W is 45 multiplied by 9.81, and my By is mu NA from equation 1, and my mu is 0.2. So now I can get NA from here. Which is 551.812 Newton. So my By equal to Bx will be 0.2 multiplied by NA, which is 551.812. So my By and Bx will be 110.36 Newton. So now we calculate Bx and By. Then now we consider this rod only, and we can do the moment balance analysis. This is C, this is P. And this is my Bx, and this is By, which are equal to each other. Now if I do the moment balance at point C, then we will have a moment due to By and Bx. And we can easily calculate the external unknown moment. So if we do the summation of moment at C, anti-clockwise is positive, then Bx will create clockwise movement, and By also create the clockwise movement. So both of these are negative. So my Bx will be 0.4 meter from point C, and By will be 0.3 meter from C. We have given these dimensions here. Then there is an external movement in the anti-clockwise direction. So my M is, so Bx and By is same, so I can take it common. And Bx is 110.36 multiplied by 0.7, and if you calculate this, you will get M, which is 77.3 Newton meter. So this is our external movement. So just to recap, we need to find the external movement in the rod. So first we consider the rod and we identify if we take the movement just to calculate the external movement, what are the forces it will require. So we found that Bx and we need to gather the data about Bx and By. So we will get Bx and By from when we do the force balance or the moment summation in the disk. And when we do this, we actually get the information about Bx and By. So it came after we take the summation of force in the horizontal and vertical direction, and when we took the summation of movement. Once we got this Bx and By, then now we consider rod again, and we do the movement balance analysis to calculate the unknown movement. So the similar concept we will be using when we have a wedge problem. Then we have to consider the blocks separately and then the wedge separately, and we have to do the force equilibrium for the block and wedge separately, and then we need to calculate the unknown forces. So any doubt in this one?
In this system, now the only weight is the self weight, that is the mass.
So yeah, so weight, we have given the weight for only this disk. We don't given the weight for the bar.
Yeah, weight, that is 45 into 9.81. But how come we are getting the normal reaction more than that? Actually, there is no other force acting on the system. The normal reaction is getting 551, whereas the weight of the system is 450.
I mean, you can get this, right? There are other forces which are acting on the system. So when you do the force summation of force in the vertical direction, the normal reaction is not balancing the weight. There are other forces also, and that force is actually this By. That force is actually here. So here you have another vertical component of the force, and due to this component of the force, the normal reaction not exactly balancing the weight of this disk. If you remove this force, if you remove this part, you will only have a disk. In that case only the normal reaction will be equal to the weight. So whatever the weight you have, it will either be equal to the weight or it may be the less than the weight. But here in this question, since you have other vertical forces, it can go above the weight also.
Okay, I will try. I didn't understand.
No, the thing is, you have a different, so you actually cannot, in this problem, you actually cannot balance the normal reaction as well as the weight, because you have other quantities. You have extra vertical forces, which is By and other forces here. And due to this extra vertical forces, the normal reaction here cannot be just balanced by the weight. You have to consider this extra quantity, so it can go beyond weight also. Because if you have a disk which is at rest and there will be a normal reaction and there will be a weight, then this normal reaction, the amount of this normal reaction will be due to this weight plus some other forces, some other extra forces, which is in this problem due to this reaction force at B, which is By. So this combination of these extra forces and weight will give normal reaction. So we have a weight plus extra forces, which is due to By, which is balancing the normal reaction. So it is weight plus this external force. So it will come more than the weight, because we have another force which is due to this joint.
So basically, there are reactions of hinge joint on the wall transferred to that location.
Yes.
Okay. Yeah, got it.
Okay. So now let's move to the wedge one. So here we need to do the same thing. So first we need to consider this box, then do the force, summation of force or movements. Then we need to consider the bottom one and do the same, just like we have done here. So here the question is, determine the smallest horizontal force P required to lift the 200 kg crate. The coefficient of static friction at all contacting surface is 0.3, neglect the mass of the wedge. So we are given the mass of this crate and we need to neglect the mass of this, and we are given the coefficient of friction between all surfaces. So first let's consider only a crate. There will be a weight, there will be a normal reaction, let's say it's NA, and there will be a friction force which is FA. Then there will be a normal reaction due to this wedge also, this wedge, and it will also offer friction. So these are the forces which are acting on the upper body A. So this is my body A, and this friction force, this friction force in all the body is this. So this is for wedge. B is representing the wedge. So let's do the summation of force in the horizontal direction. So we have FB minus NA. So it will be mu NB equals to NA. And if we do the force balance in the vertical one, then we will have NB minus WA minus NA. So here NB minus NA equals to 200 multiplied by 9.81, which is WA. So I can use equation 1, which is NA equals to 0.3 NB. And I can put this equation 1 in equation 2.
That is mu NA.
Mu in
NB minus W minus.
Oh, yeah. It is a mu here. Yeah. Because this is force FA. So let's find NB first. So if I put equation 1 and equation 2, I will have NB minus mu, which is 0.3 multiplied by 0.3 NB equals to 1962. So this will be 0.91 and B equals 1962. So my ND will be 2153.86 Newton. And from equation 1, I can have Na equals 0.3 Nb. So it will be 0.3, 2153.846. So Na will be 646.15 Newton. So this is my Na and this is my Nb. Okay. So now let's consider the wedge. And here we have NB, here we have FB, and we need to find the external force, which is P here. This is P. And there will be a friction force due to the bottom block as well, which is, let's say, C block. So there will be a normal reaction due to C block, which is NC, and this is at 15 degree. Again, this will be 15 degree. And there will be a friction force FC in this direction. This will be my friction force FC. So if I do the force balance analysis here for block B, summation of force in the vertical direction, I will have contribution of the force due to this NC, which is NC cos 15, and due to this component of friction force, vertical component of the friction force is FC, which will be minus F sine 15, and due to this NB, which is minus NB equals to 0. And we know NB, so this FC can be written as mu NC. So only unknown force is NC here. So it will be NC cos 15. So let's first do the summation of force in the horizontal direction as well, because it will give information about unknown force P. So it will be P minus FB, and due to the segment of NC as well as FC, so it will be the horizontal component of NC, which is minus NC sine 15, and the FC, which is going in this direction, so this will be cos 15, and here we need mu NB minus mu NC sine 15. Sorry, this is not mu. This is NC cos 15 equal to 0. So we need the NC here. So the NC can be determined from equation 1. So from equation 1 we have NC cos 15 minus mu NC sine 15 equals NB, and we found NB as 2153.846. And mu is 0.3 in all direction. Sorry, for every surface. So it is 0.965 NC. 0.077 NC equals to 153.846. Point 888 and C equals 2153.846. So NC will be 2425.502 Newton. So this is my normal reaction at C. So now we can use this normal reaction at equation 2 here to find P. So P will be mu NB plus NC sin 15 plus mu NC cos 15. So P equals 0.3 to 153.846 plus 2425.5 multiplied by sin 15 is 0.258 plus 0.3 multiplied 2425.5 and cos 15 is 0.965. So this term will be 702.85. This term will be 625.77 and this will be 646.14. So my external force will be 1974.76 Newton. So this is my external force. So just to recap, you need to find this external force P, and in this problem we actually consider multiple bodies separately, and then we do the summation of force and moment separately in each body. So first we consider the rectangular block A, and we do the summation of forces here, and we found normal reactions at A as well as normal reaction at B due to the body B also. Then we consider the wedge here. We again do the summation of forces here, and first we found the normal reaction due to the bottom body C, which is NC, and again by the same procedure, summation of forces in the horizontal direction, we actually found the external force P. So this will be the concept for the wedge. So it doesn't matter if you have a two wedge or two body system, like you have given this or this kind of a body. You always try to do the summation of force and movement separately for each body, and then keep calculating the forces by summation of forces at each body, and in that procedure you will get the required unknown force. So any doubt in this one?
No.
So that's it for today. So there is one more question left here at the bottom, which is again from the same concept. So you have given two blocks and you need to find the force, unknown force F. So again you have to do the same thing. you have to consider block A first, determine all the forces, draw the free body diagram. So this is your, let's say, R, this is your mu R, and this is your mg. Do the summation of forces and then consider the bottom one and do the same thing, and mu n, weight of body B, which is mvg, and mu sn, and then try to calculate the unknown force F, which is acting on block A. So similar procedure, you just need to find the force F here, and the procedure is exactly similar to the above one, by doing the summation of force in body A first and then body B. So because if you write the summation of force in a body A first, you will have a force F which is written in terms of an unknown force, and so on. Then if you write down the summation of force in body B, this you can actually write N in terms of R and N2, which is here. Then solving these two equations together, you can actually calculate the unknown force F. So try to calculate this by yourself, and if it is not, then I can start in next week with this question. So the procedure is similar here. So from the next week, I also start kinematics and kinematics problems. So that's it for today. Thank you.
Thank you, sir.